All right, so we're going to do number 6 here, where it asks us to calculate the energy released by this amount of mass, and then how many kilograms can be lifted to this height by this amount of energy. One thing to be careful of is make sure that you're in base units of kilograms, meters, things like that. Because I've seen a lot of people make the mistake on part B here and not think about that that's 9 kilometers, and they should convert that to meters before, say, they do the gravitational potential energy, or they convert kilograms to grams. They don't think that kilograms is the base unit, but it is. So we'll go number 6 here. Up a little bit. And the main concepts here are things like that the energy and matter are the same stuff. So, equivalent. And it's always good to look at the problem and say, okay, well, I've got this much mass, this much matter. Do I expect that to be a lot of energy, a little bit of energy, or kind of in the middle? What do you think? A lot of energy. So I would express that as matter is a very concentrated form of energy. And then the second part of this, where they're asking me to lift, how many kilograms can be lifted 9 kilometers in height? I can either, there's 2 ways I've approached that. One, I know that when I lift something, because I have to apply a force to it in the direction that it's moving or it's moved, I do work on it. Well, that's good review for the final exam, isn't it? Work and energy are on those. In fact, they're a big part of it, to be honest with you. Or I can think about it as, oh, that work I do changes the gravitational potential energy of the object. So I can look at it either way. I'm going to choose to look at it as gravitational potential energy. So I'm going to put in here that lifting the mass increases its PE, potential energy, gravitational. So that's what you could also, though, again, look at it as the work done on it. So equation-wise, grab my capture thing, grab my equation sheet. For the first part, I just need the amount of energy stored in this equation. E equals mc squared. And quite frankly, this is part A. I want to know the total amount of energy. I have the mass. I have the speed of light, right? 2.9979 times 10 to the 8th meters per second, quantity squared, and I'm done. Yay! For part B, I would go back and look at my equation sheet and remember that back here on this page, I had gravitational potential energy, which is mgh. And so for part B, I have the amount of energy, that's the P grav, G, I'm going to assume it's on the Earth. That's going to be 9.80 newtons per kilogram. And my H, for me, I'm going to use, I think it's 9,000. Yep, 9,000 meters. And then I just solve for M. And I'm all done. M stands for mass. Yes, the speed of light, as found on your equation sheet or stored in your calculator, is 2.9979 times 10 to the 8th meters per second. All right, let me know if you need help individually on the math of that. All right, so we're going on to number 5, which basically the exact same reasoning as number 6 that we just did. I'd probably put it in there word for word, except I'd leave off that part about potential energy. But so you have the, matter is energy. You have that this is a concentrated form. All of those fun things. And then you come over here and you have E equals mc squared. You're given the amount of energy this time. So you're given this. You know C because you know what universe you live in, and you're asked to find M, I believe. Yep, in kilograms. You nicely have things in joules already. So not even any need for conversion. Basically, it's plug in your numbers and rearrange, solve for M. There you go. All right, we're going to do number 1, which was requested by an illustrious member of the class. So. Well, no, you guys have been gone for a while. Everyone else has been back. You guys, see, I wasn't moving very fast. So. Go ahead, finish that thought. Okay, I will believe that. I think I didn't unfreeze the screen. There we go. All right, so we've been asked to do number 1. What is the momentum of a proton traveling at this speed? Gotta love protons. This is number 1. And let's see, you should remember that speed of light is constant from all frames of reference. And that momentum is based on your frame of reference. Since inertia and speed are relative. So since momentum is based on the amount of inertia the object has and the speed it's moving, and both of those are relative or based on your frame of reference, then the momentum is relative. It's the overall idea here. And we need, let's see, gotta get down to the bottom here again. And the equation we need, remember that P stands for momentum. So we need that. And because we're going from one frame of reference to another, we should use that. The other thing probably to have here in your Y might be that momentum increases the faster you move. So that might be good to have in here. The faster, the more momentum. And it's actually a double whammy here because not only does the inertia increase, but the speed increases also. So in this, really, you just have to remember that P is momentum. You have the value for gamma here. Remember, the V is how fast your frame of reference is moving. The M is the mass of a proton, which is found on the back of your rubric. Let's see, where is it? Right down here. Mass of a proton, 1.672 times 10 to the minus 27 kilograms. So 1.672 times 10 to the minus 27 kilograms. And U, of course, is the same as V. It's how fast you're moving in that frame of reference. Most common mistake will be to underestimate your speed, because like my speed is 0.86 C, and people will forget that C is there because they're so used to seeing it and forget that that is 2.9979 times 10 to the 8th meters per second. So don't forget that. So when you're looking for momentum here, you're plugging in, you have M, you have U. I'm just going to put V in there just to remind you, and 1 minus, and I always group these as V over C, quantity squared. You have everything in there except P, and so just solve it. Put in your numbers. If you need help with the individual math, let me know, and I'll be glad to come and help you. Yes, V stands for speed.